Here's a couple of questions from the textbook just regarding understanding of angles and the ratios of those angles. So in this question it says find the reference angle and find the exact function value if it exists. So they want to know what the cosecant of 225 degrees is. So first thing is to find out where that angle is. If this is always our initial arm, 225 would be, here's 90, 180, and then I got to go another certain distance to get to my 225. Now that other certain distance would be known as your reference angle, because this angle here that your terminal arm makes with the closest x-axis, okay, this is x, this would be called your reference angle. So if I've got 180 to there and my whole angle is 225, I can go 225 minus 180 and that'll give me my reference angle. So really, asking for the cosecant of 225 degrees is the same thing as asking for the cosecant of 45 degrees, with an accompanying sign change in there, a plus or minus if you need it. Now, my problem here is that off my chart, I have sine, cos, and tan for 30, 45, and 60. So there's a 45 there, but I'm looking for cosecant, not one of these. So my next thing would be is to figure out what reciprocal this one would go with. So cosecant, it always changes the first letter, so it's the same as sine, or it's the reciprocal of sine. So cosecant of 45 is the same thing as the reciprocal, so reciprocal of sine of 45 degrees. Again, with an accompanying plus or minus in there if I need to. So basically all I have to do is figure out what the sine of 45 is and then flip it over. So if I look here off my chart, the sine of 45, this spot right there, if you've memorized that from your chart, is root 2 over 2. So if the sine of 45 is root 2 over 2, then the cosecant of 45 has to be the reciprocal of that, or 2 over root 2. Now, root 2 on the bottom, that's a thou shalt not. You can't have a radical on the bottom. So you'd multiply top and bottom by root 2, and you'd come up with 2 root 2 over square root of 4, which is 2. The 2's cancel, so you would just come up with root 2. Okay, so the only other thing we have to worry about is this sign change. So the sine of 45, that's down here. So I have to figure out what the sine is in this quadrant. If you remember that cast rule, you could use that. Or if you think about in this quadrant, what is the value of sine is what is the value of y. So remember y and sine go together. So the value of y down here is negative. So therefore the value of sine is negative. And if the sine is negative, so is the cosecant. So all of these should be negative. So it'd be negative 1 over 45, negative this, or negative that, and my final answer will be a negative root 2. So the cosecant of 225, negative root 2. Let's just go through it again. Cosecant of 225, I find my 225 angle, find my reference angle is 45, so the cosecant of 225, same as the cosecant of 45. But cosecant is a reciprocal ratio. So figure out what the sine of 45 is and then flip it over. From my chart, sine of 45 is root 2 over 2. So to figure out the cosecant, I flip that over. So it's 2 over root 2. And then from this point here, I just rationalized. So that's the one thing you have to worry about, figuring out the ratio, and then you figure out what value it should be, whether it should be plus or minus. And since down in this quadrant sine and y are both negative, cosecant is also negative. So negative root 2. Let's try another one. So this one here, if I can extend, the cotan of negative 90. So let's figure out where that is. That would be right there. So negative 90 you go down or you go clockwise, and so it's 90 right there. So tan of negative 90 is going to be the same as, if I express it as a positive angle, the cotan of 270 degrees. So both those mean the same thing. They're coterminal lines in the same spot. Now the reference angle to the closest 90 degrees, or the closest x-axis, is 90. So really the cotan of negative 90 or the cotan of 270 should be the same as the cotan of 90 degrees with an appropriate sign change if needed. Okay, you always have to remember that sign there, whether it's plus or minus. Now cotan of 90, well, I don't know what that one is. However, if I go to my chart up here, tan 90 is not on my list. So maybe what I can do is, instead of cotan, it's 1 over the tan of 90 with an accompanying sign change if needed. So the tan of 90, so I could just do that on my calculator, go tan 90, and then flip it over. Tan 90 should come out to, the tan would be a y over x would be 0. So the tangent of 90, that's sort of a funny one. The tangent of 90 will be, let me just write it over here. If I'm just doing the tangent of 90, that's equal to y over x. And y at this point would be some kind of a number. I don't know what it would be. We'll just call it y. But the value of x right on this point here, it's not moved left or right, so it would be 0. So the tangent of 90, if you tried that on your calculator, you're probably going to get an error, or bzz, can't do it. But this is the ratio that I wanted to look at right there. So if the tangent of 90 is y over 0, then the cotan of 90 is the reciprocal of that, or 0 over whatever y is, or 0. So the cotan of negative 90 would be 0. Hopefully that kind of explanation helps you out a little bit. Here's just one last question, and it deals with figuring out what the signs, and when they say signs written like that, it's plus or minus. The other way, this is for the actual sign ratio, but this is SIGN, so they're looking for whether it's plus or minus. Of this angle, 319. So 319, 90, 180, 270, 319 is going to be somewhere in here. I guess I could figure out a reference angle if I want, but all they want to know is whether it's going to be plus or minus in this quadrant. So I could, for all those six trig functions, so I could do sine, and its reciprocal would be cosecant, cos, its reciprocal, and tan, and its reciprocal, cotan. So down here, if I'm looking at sine, it's below the x-axis here, so the value of y is negative, therefore sine's negative. So both of these, sine and cosecant, will both be negative. Now cos, in this quadrant here, it's to the right, and cos and x go together. X is positive because it's to the right, so both cos and secant will both be positive. Now the last one, tangent and cotangent, is a combination of those two, because tan of any angle is y over x. If y is negative and x is positive, if you divide those two, a negative divided by a positive is still going to be a negative. So the value of tangent and cotangent in that quadrant are all going to be negative. If you wanted to try that on your calculator, you could do that. Pick that angle 319, hit sine of 319. It's going to be negative something. Cos of 319 is going to be positive something. And tan of 319 is going to be negative something. Okay? Hopefully that helps you out with those questions.